All right, example 27. It says the region bounded by the curve y is equal to 2 over x and y is equal to 3 minus x is rotated 2 pi radians about the x-axis, where to calculate the volume of the solid formed. All right, so earlier we would have said that something that is very important to find in this volume is to determine the point of intersection of the two graphs. So let's talk about point of intersection. All right, so the point of intersection is common to intersecting graphs. So therefore, at the point of intersection, x and y for both graphs are equal. So at the point of intersection, y for one graph, which is 2 over x, is equal to y for the other graph, which is 3 minus x. So these two things being equal only occurs at the point of intersection. If I multiply the entire equation by x, I'm going to get 2 is equal to 3x minus x squared. So what I have is a quadratic equation to solve. Let's got everything on one side and 0 on the next side. So I have x squared minus 3x plus 2 is equal to 0. So I'm going to factorize. So x here, 2 here, 1 here, negative, negative. Therefore, x minus 1 is equal to 0, or x minus 2 is equal to 0. Therefore, x is equal to 1, and x is equal to 2 are the values of x at the points of intersection of the two graphs. All right, another thing I like to do sometimes is, I like to do a sketch of my graphs just to get a visual appreciation of what I'm dealing with. All right, so I'm just doing a quick sketch, nothing special. All right, so y is equal to 2 over x, will probably look something like this. All right, and my next graph is y is equal to 3 minus x. 3 minus x would look something like this. All right, let's try something. These are different. 3 minus x might say look something like this. And the two graphs intersect at x is equal to 1 and x is equal to 2. All right, so this is my y-axis, this is the x-axis, this is y is equal to x over 2, and this is y is equal to 3 minus x. So of course this intersects here at 3. It's not the best sketch, but for what we have to do, it's okay. So now we have all the information that we need. And what we're calculating is the volume that is generated when the area that is enclosed by these two graphs is rotated 360 degrees about the x-axis. So, of course, that volume is going to be equal to, that volume V is equal to pi, the integral from 1 to 2, those are my limits, of y squared. So y is 3 minus x squared dx minus the integral from 1 to 2 of y squared, which is x over 2 squared dx. So this is the both. So what this is simply the volume of the solid. The volume of the solid of revolution of the higher graph minus the volume of solid of revolution of the lower graph. All right. So that's essentially what this is. So let's do them one at a time. So for the first one, we get V is equal to pi, and then let's integrate. we're going to have 3 minus x, raise this to the third power, put this over the new power, which is 3, and then I have to also divide by the differential of the inside function, which is minus 1, and this is for the limits 1 to 2. Let's pull out the minus 3. So we have this is pi or minus pi over 3. And then we have 3 minus x. 3 minus x raised to the third power. This is 1 and this is 2. All right. So this is going to be equal to pi minus pi over 3. And first, let's replace x with 2. So we have 3 minus 2 cubed minus, then replace x with 1, 3 minus 1 cubed. All right, so what we have is v is equal to minus pi over 3, and in bracket, 3 minus 2 is 1, 1 cube is 1, minus 3 minus 1 is 2, 2 cube is 8. So our volume V is equal to minus pi by 3 times minus 7, and negative times a negative is a positive. So this is a positive 7 over 3 pi cubic units. All right, so that is us finding the first integral. Then next we have to find the second integral, and then lastly we have to subtract. All right, so the second integral is equal to pi, the integral from 1 to 2. What was it? It's 2 over x squared, so it's 4 over x squared dx. All right, let's put out the 4. So we have 4 pi, the integral, 1 over x squared becomes x to the minus 2 dx. This is from 1 to 2. When we integrate it, increase the power by 1. So we have 4 pi. When it increases power by 1, it becomes minus 1. Divide by the new power minus 1. And this is from 1 to 2. So this becomes 4 pi. And then we have minus 1 over x. And this is from 1 to 2. We can pull out the negative if you want. So we have minus 4 pi. And then we have what? 1 over 2. So replace x with what? 2 minus, replace x with 1, 1 over 1. So what we have is minus 4 pi, and we have a half minus 2 over 2. So what we have is minus 1 over 2. So this becomes minus 4 pi times minus a half. All right, and then this volume here becomes 2 into this is 1, 2 into this is 2, and negative times a negative is a positive. So this is 2 pi cubic units. All right, so the next thing we have to do, or the final thing that we have to do, is we have to subtract. All right, so the first integral gave us 7 over 3 pi. So the volume that is generated by the area enclosed by the two curves would be equal to 7 over 3 pi minus 2 pi. So this volume would be equal to 7 over 3 pi minus 6 over 3 pi. So the answer is what? 1 pi, or just 1/3 pi, and this is cubic units. All right. All right. So that's the end of it. All right.